You probably picture the Big Bang as this huge, explosive moment when our entire universe just burst into existence, right? But what if that classic picture of the Big Bang is actually missing a massive piece of the puzzle? What if the Big Bang wasn't the absolute beginning at all, but more like a cosmic rebound? Yeah, a new theory suggests our universe didn't just appear from nothing, but actually bounced into being. Like literally, it might have emerged from the inside of a supermassive black hole. This isn't some sci-fi fantasy. It's a serious idea, grounded in known physics and observations we already have. Now, the standard Big Bang model has done an amazing job explaining a lot about our universe. It's a champ, but it's also got some serious headaches. For starters, it kicks off with something called a singularity. That's basically a point so incredibly dense, our known laws of physics just throw up their hands and break down. It's like trying to divide by zero in math, it just doesn't compute. That's a pretty big theoretical problem. Then, to explain why the universe looks the way it does, the standard model adds in other mysterious ingredients, like cosmic inflation, a superfast early expansion driven by some unknown field, and dark energy, another mysterious force that's making the universe expand faster today. Basically, the standard model works, but it needs a lot of unexplained, hypothetical stuff to make sense. Our new black hole universe model tackles these cosmic questions from a totally different angle. Instead of looking outward to the Big Bang, we're looking inward at what happens when stuff collapses. Think about a star collapsing into a black hole. That's a process we understand pretty well. But what happens inside a black hole, past the point of no return? That's where things get wild. For decades, physicists like Roger Penrose and Stephen Hawking proved that gravitational collapse had to end in a singularity. Their work, based on classical physics, what governs big, everyday objects, seemed to seal the deal. But here's the kicker: classical physics doesn't account for the super tiny world of quantum mechanics. The weird rules that govern atoms and particles when things get incredibly dense. Our new calculations show that when you factor in quantum mechanics, the story changes completely. Specifically, there's a rule called the quantum exclusion principle. It basically says no two identical particles can occupy the exact same space. It's like particles needing their own personal bubble, even when things are super cramped. This rule actually prevents matter from being squeezed into an infinitely dense singularity. Instead of crunching to nothing, the collapse halts and then bounces back. It's not just possible, it's inevitable. And the cool part? This happens entirely within the rules of general relativity and basic quantum mechanics. No need for exotic fields, extra dimensions, or any other speculative physics. It's built on solid ground. What emerges from this bounce is a universe uncannily like our own. And get this, the bounce naturally explains those two phases of accelerated expansion, inflation, and dark energy, without needing extra mysterious ingredients. But here's where it gets really exciting. This model makes testable predictions we can look for. It suggests our universe isn't perfectly flat like a sheet of paper. Instead, it predicts a tiny bit of positive curvature. Imagine our universe is slightly curved, like the surface of a giant, cosmic ball, not perfectly flat. Future missions, like the Euclid Space Telescope, are already looking for this subtle curvature. If they find it, that would be a huge clue that our universe really did emerge from such a bounce. This model could also shed light on other big mysteries, like where supermassive black holes came from, or even the nature of dark matter and how galaxies formed and evolved over time. And here's the mind-bending part. In this framework, our entire observable universe could be living inside a black hole that formed in some much larger parent universe. Just wrap your head around that for a second. It means we're not witnessing the absolute start of everything from nothing, but rather a continuation of a cosmic cycle. A cycle shaped by the incredible interplay between gravity and the weird rules of quantum mechanics. If you like what you see, hit that like button and subscribe for more.